survival mechanism. It's not going to be a reproductive mechanism. So it helps it survive in extremes of temperature, drying, nutrient depletion, anything that's adverse in the environment. Also, it aids in dispersal of the microorganism by wind and water when they release those endospores. Those endospores can be blown by wind, and then they can germinate and give rise to vegetative cells again. Read the box in your book about how long endospores are thought to survive. I mean, it's really, it's really interesting. They talk about some archaeological findings and so on that even imply they would go millions of years. We know they survive for extremely long periods of time. Usually what stops their survival is UV radiation. So if they're out where they contact UV from the sun, they typically don't survive as long. But read that section. It's very interesting. It's a little box in your book, and you'd be surprised if you read that. Most endospore-forming bacteria are found most commonly in the soil. Most notable genera they will teach you about is Bacillus and Clostridium. Although in the lab we also teach you about Spora sarsina. Bacillus and Clostridium are gram-positive rods. You'll need to know that for your lab exam. And the way we distinguish those is which one's aerobic? Bacillus. Which one's anaerobic? Clostridium. Okay. How do we contrast these two with Spora sarsina? This is a coccus, where these two are rods. So know that for the lab. When you look at the structure of an endospore, basically from this point on, it's like a cell. But it has all these outer layers. An exporium, okay, consists predominantly of protein. It has a cortex. Well, it has a spore coat first. And the spore coat is real thick, and it's also protein. It's got the cortex that is peptidoglycan, so it's a wall-like protective. Okay. And then we start in and get something just like a cell. So if you look at this, hold on, get it to go. It's got a cell wall. See, there's a cell wall. It's got cell membrane. It's got the internal constituents of cell, DNA, ribosomes, and so on. So actually within that endospore is the potentials, the DNA that codes for all the properties of the cell. So is it a wonder that this endospore can give rise to a vegetative cell? It's got the DNA there. Now, it's for survival, not for reproduction, because when we go the cycle, we start with one microbial cell. It forms an endospore inside. Then as it matures, that endospore is released as the cell lyses, so we don't have the cell anymore, we just have the endospore. It germinates, gives rise to a vegetative cell. We start with one, we get one. It's a survival mechanism, not for reproduction. Did we tell you about the curve? Real quick. Bracken, I think, uploaded already. We added 10 points to everybody's grade. Okay. I didn't add more right now because we had so many in the good high grade. So adding 10 to a 96 is 106 points. Okay. So basically, you made an 80 or above, we add 10, you're already at a 90. We will probably adjust the scale later on. I adjust the scale lower for B's, a little bit lower for A's. But right now, just if you're close, you're fine. And Bracken has already added that there should be 2 columns now. If you did it right, your regular grade percentage, and then
okay, so the LPS layer is highly heat resistant.